So how would you name this compound? So this compound here is in what we call the chair conformation. You can also look at it like this for the most part. However, when you start to see these chair conformations, stereochemistry comes into play, as we'll see here shortly. So you can really draw this out to resemble what we see on the left, and this would be essentially it. So this is the same as this, with the exception that you can't see up or down. So if you would draw a line between this compound, these hydrogens are on top, and this methyl and this alcohol group are on the bottom, so they're on the same side. It's impossible to tell if you draw these hydrogens out here which side it's on. You can look at this hydrogen and think it's on the front or the back. You can look at this methyl. So in order to see that stereochemistry, we have that shape on the left called the chair conformation. All right, so how would you name something like that? You're going to start numbering from the carbon with the high substituent on it. In this situation, it's the alcohol group. So we start numbering at that carbon: 1, 2, 3, 4, 5, 6. So each of these points and dips are carbons. So we have a hex. It's not really a hexane because it's an alcohol, so we just go ahead and just name that the hexanol. So again, the OH determines that it's an alcohol. 6 carbons determines that it's an hex. So on this 3 carbon here, we have the methyl group, so that'll be 3 methyl. So this will be 3 methyl hexanol. And if you were just looking at this conformation here, that's all you can name it, is 3 methanol. However, we do see that if we draw a line through the plane of this chair conformation, that this methyl group and this alcohol group are both on the same side. So this will be cis 3-methyl hexanol. So stereochemistry is important with these compounds. Now, if one of these, let's just say that the methyl group here was on top opposite of this alcohol, it would be what you call a trans, and we'll try to work a problem like that as well. And all cis is, these functional groups are on the same side. If you have a functional group on this side, and we're talking about functional groups only, not the hydrogens. So if a functional group is on, let's say if the methyl was up here, this will be a trans. And to add and correct my mistake that I just made here, this will be cis 3-methyl cyclohexanol. Anytime you have a ring compound, you have to indicate that it's a cyclo. So anytime you have a ring like this, make sure you add the cyclo in front of whatever the main compound is. So this is incorrect. This is cis 3-methyl cyclohexanol.